Okay, so this is going to be your screencast for evidence for chemical changes. Basically, when you're looking at any type of a chemical reaction, there's some things that might happen that allow you to know that this chemical reaction has happened. The first one is a solid formation. That's called a precipitate, meaning a something is going to settle out of solution. So you're going to have a solid settle out. Like if I take sodium chloride and silver nitrate, which are both liquids, they're both aqueous solutions. I mix them together. I get sodium nitrate, which stays dissolved, but this cloudy mixture of silver chloride forms and settles out of solution. So that means I made this new solid that wasn't there before. So that's a precipitate. You might see a color change, but not always. You might see gas formation or like bubbles coming off. The technical term for that is effervescence. So it might have effervescence with it. And then a temperature change, either increase or decrease in temperature. But remember, some of these can mean that you just have a physical change as well. Like when I boil water, it bubbles. But that's just a physical change. So these are generally, the things we look for to tell if a chemical reaction has happened or not. And since energy, when we talk about chemical reactions and temperature, energy can neither be created nor destroyed. So we have to have a way to kind of keep track of energy. And that's what enthalpy is. Enthalpy is this concept of heat energy within the system. And we show it with the symbol delta H. Delta just means change in. So we have a change in heat or a change in enthalpy. So looking at this, there's two types of reactions when you're talking about heat energy. There's exothermic. Exo means out. Therm means heat. So this is heat out, meaning the system, so the reaction system is going to lose heat to the surroundings. The surroundings are what you feel. So these are going to feel hot because the reaction is losing energy. So we say it has a negative delta H because energy is being lost from the system to the surroundings. So my products now have less energy than what they started with. And we can show this on an energy diagram. So if I'm allowing this reaction to happen over time, I can look at how much energy I had. So my reactants are going to start at some energy level. If it's an exothermic reaction, that means once the reaction is finished, so over time, my products are going to be at a lower energy level than my reactants were. So this difference right here, that is my delta H. And it's going to be negative because the heat energy is being lost to the surroundings. If I had an endothermic reaction, that is the other type of reactions. So if I have an endothermic reaction, endo means in, therm means heat. So in this case, the system is going to gain energy from the surroundings. So because the system is taking it in and using it, the surroundings are losing it. This is going to make the surroundings feel cold. So if you were to look at like the reaction like happening inside of this beaker, if the reaction, that is the system in there, heat energy is being taken from the surroundings. So it's going to feel cold all around it. Another way to show this is a positive delta H because the reaction is gaining heat energy. It's stealing it from the environment. So it's a positive delta H. My products have more energy than the reactants did to start with. So the way that an energy diagram would look here, if I'm looking at energy over time, my products are going to end at a higher level than my reactants. So this amount of energy right here that I gained, that's the positive delta H. And where did I get it from? From the surroundings, which is why this outside area is now going to feel cold to the touch. So that pretty much covers exothermic and endothermic reactions, enthalpy, and how to tell if a chemical change is occurring.